Hello students, today we are going to see something different. Alkyl halide reacts with potassium cyanide. Alkyl halide reacts with silver cyanide. What is the product? And the same way alkyl halide reacts with potassium nitrate and silver nitrate. What is the product? So these are the four reactions we are going to see. Come on, let us see to that. So Rex. General formula I have taken combined with KCN. What you will be getting? Of course, RCN. And here you will get it what it is? KX. Okay, I just put it general formula only. RCN, it is what it is? Alkyl cyanide. What do we call? Alkyl cyanide. But here the same alkyl halide combined with AgCN, you are getting RNC plus the same thing AgX. AgX. But here, what do we call here? See here, what is the difference? CN. But here NC, isocyanide, alkyl, isocyanide. Okay, now why this different answer we are getting? Let us go and watch. Because both are cyanide compound only, but here we are getting alkyl cyanide, but whereas here we are getting what it is? Isocyanide. Okay, now let us go for that something example. CH3, CH2, Cl combined with KCN. The same thing only you will receive CH3, CH2, CN. What is this? Come on. Ethyl cyanide. Very good. Ethyl cyanide. But whereas here the same CH3, CH2, Cl combined with AgCN. What you are going to receive? CH3, CH2, NC. Very good, very good. I can hear your voice answer. Okay, AgCl. Now, come to this point here. Ethyl. Come on, ethyl. Very good. Isocyanide. Okay, now what is that different? Why? What is the reason we are getting such kind of different product? Okay, let us go and watch that. Okay, now I'm going to give that reason why we are getting a different answer, different product. Here, the reason it is very simple. Potassium cyanide is a ionic in nature, whereas silver cyanide it is a covalent in nature. Ionic in nature completely ionizes, but whereas covalent in nature it does not ionizes very easily. And the second point, cyanide ion, it is an ambident nucleophile. What is it, ambident nucleophile? It is actually two different atoms can be act as a nucleophile. Now, in this, carbon acts as a nucleophile when it attaches to that potassium cyanide. Okay, now in this, here completely ionizes. Now carbon acts as a nucleophile and it attack that halide ion. It will become RCN, cyanide, alkyl cyanide. You will get it. Whereas here nitrogen acts as a nucleophile. Why? Because nitrogen has two lone pair of electron that acts as a nucleophile and it will attack that alkyl halide. So what you will get it RNC. It is isocyanide, alkyl isocyanide. So that is the reason here you are getting different product. In one thing, carbon acts as a nucleophile. Here also, carbon it is dominating. Whereas here, nitrogen is attacking that nucleophile. So, nitrogen it is dominating. So, who is dominating according to the product you are receiving? Hope you're clear. So, this is isocyanide and this is cyanide. Common it is alkyl only. Alkyl, here also alkyl only. Okay, so hope you're clear with that. KCN you are getting alkyl cyanide, whereas AgCN you are getting alkyl isocyanide or NC. Hope you're clear with it. Please note down, take that screenshot. Hope it is clear for you. Now the next, here also something different product you are getting. Here action on KNO3. So alkyl halide reacts with potassium nitrite. This is called what it is, potassium nitrate, in the presence of alcohol. You are getting what it is, RONO plus KX. Yes, in this place, what is the name we can find out? Alkyl nitrite. Alkyl nitrite. Whereas here the same RX combined with AgNO3, you are getting what it is? Can you guess? RNO2. And here what it is? AgX. Okay. Now here what it is? Nitroalkane. Nitroalkane. So, what is the reason? Here, in a simple way, I'll tell you. Alkyl nitrite, it is RONO. Nitroalkane, RNO2. Nitrite ion, it is a amphibian nucleophile. Amphibian, I think you might have heard about that. Amphibian, it will live in land as well as in water. Yes, here amphibian nucleophile means different. Both the atom acts as a nucleophile, but where it will act, that is a matter. Now that nitrite ion, when it is combined with potassium nitrite, it is a ionic in nature. In that place, oxygen acts as a nucleophile and it will attack that alkyl halide. So what you will get it, RONO. Already I just mentioned now whom it is dominating. That is the product you are receiving. So here what it is, alkyl nitrite. Whereas here silver nitrate, it is a covalent in nature. Silver nitrate, it is a covalent in nature. In that place, nitrogen acts as a nucleophile. Why? Because it does not ionizes very easily. Nitrogen has two lone pair of electrons. That lone pair of electrons which will attack the alkyl halide. So automatically what is that product you are receiving? RNO2. So that is what I just mentioned in the last point also. Yes. Now here nitroalkane you are receiving. So hope you're clear with this. Why we are getting a different product here, alkyl nitrate, here nitroalkane. Why? What is the reason? Because it is a hampident nucleophile. When it is combined with potassium nitrate, you are getting alkyl nitrate, whereas when it is reacts with silver nitrate, it is you are getting nitroalkane. Hope you're clear. Just take that screenshot if you want. Thanks for your support. Thanks for watching.